Okay, so last thing. This is the last thing in the chemistry unit, the mole. Okay, and the mole equation, most importantly. So as its name would imply, there's some calculating involved here. Right? So you're going to need a calculator over the next couple of days. You can get by with the one on your phone for today probably, but okay, you will certainly need one for your unit exam next week, so make sure that you beg, borrow, or creatively acquire one by that time, because you can obviously not use the one on your phone during an exam situation. Okay, so make sure that you have a scientific calculator at the very least, okay, for next week for the exam. All right. Now, the mole equation, or the mole, the idea of the mole is to serve a specific purpose, and that is to represent an unfathomably large number with a smaller number. Okay, that's what the purpose of the mole is, right? So an example of this is something we do all the time, right? When you buy eggs, how many do you buy at a time? Okay, you buy a dozen, which is how many? Yes, it is, but okay, and we're talking about a real dozen here, and a real dozen is always 12. Okay, well, the mole works the same way. The mole always represents the same number of particles. Okay, if I'm dealing with an element, the mole represents a certain number of atoms. Okay, if I'm dealing with a molecule or a compound, okay, then the mole represents that same number, but now of molecules instead of atoms. Right? It always deals with the smallest particle of that particular material. Okay, so if I have 1 mole of, let's say, sodium, I have this many atoms. 6.02 times 10 to the 23. Okay, that is a very big number. It is 602 with 21 zeros behind it. Okay, why does it have to be such a big number? Because atoms are stupidly small. Okay, and even a teaspoon of water would contain an unfathomably large number of atoms. Okay, even more than that in a teaspoon of water. Okay, everybody follow me there? Okay, so atoms are really, really small. It is inconvenient and impossible, quite frankly, to deal with them in like, oh, well, this reaction is 3 molecules of this reacting with 2 molecules of that, and it produces 4 molecules of that stuff. Well, no. Okay, that may be the ratio in which it happens, but we would never see a reaction that dealt with that small of amounts of materials. All right, so the mole represents large numbers of particles, okay, with a small number. Right, so this number here is 1 mole. 6.02 times 10 to the 23 is 1 mole. All right, so it's a unit for measuring the number of particles. Okay, what we got to get out of today is understand how we can use that in what we call the mole equation, which is the relationship between moles, mass, and molar mass. Okay, and then use the mole equation to solve mole equation problems. There are only 4 kinds of mole equation problems. We will go over all 4 each and every day this week. So you will see, or you will have podcasts of me solving the 4 ways I can ask you a mole equation question 4 times. Okay, so you have lots of examples that you can go over. All right, so how did they come up with this number? Somebody just pull that number out of a hat? And just wait outside, please. Be right up. Okay, so how did we come up with this number? It's not something that someone just pulled out of a hat, okay, and said, well, I'm just going to pick that number because it sounds cool. Because nobody would pick that number. Okay, that's just a weird number to pick, right? It came down to this. A guy named Avogadro, the guy who came up with this idea, okay, he was trying to come up with a way to represent large numbers of particles with small numbers, like a dozen does. He said, because it's too difficult to try and do this and figure out how many particles are in there. So he took the simplest atom, hydrogen, okay, and he said, I'm going to take 1 gram of hydrogen gas and figure out how many atoms are in there. And then I'm going to use that number to represent everything else. Okay, so that's where we get all of these molar masses from. Okay, all of our atomic masses on our periodic tables here. You can see that the atomic mass of hydrogen is just a slightly more than 1 gram. Okay, 1 gram of hydrogen has that many atoms in it. Okay, That's where he started it with. And then he said, okay, there's my magic number, 6.02 times 10 to the 23. Now I'm going to figure out what the mass of that is for every single atom on the periodic table, which is why every single element has a slightly different atomic mass, because every single element on here has atoms that are different. Okay, we learned that the very first day. That was Dalton's atomic theory, right? All atoms are different. Okay, atoms of different elements are different. So hydrogen, being the smallest and simplest atom, has one proton and one electron. Okay, very, very simple atom. Helium, okay, it's got two protons, okay, two electrons, and according to its molar mass, also has two neutrons. Okay, so obviously it's quite a bit heavier, okay? And so on and so on. Obviously, as we go down the periodic table, the atoms get bigger and bigger and bigger, which is why the masses get bigger and bigger and bigger. Okay, everybody with me so far? All right, so we can express the amount of a substance in grams. If we happen to have, a pile of it, we can put it on a scale and take its mass, okay? Or we can express it in moles, okay? Either way is equally valid, okay? It could just as well be a quantity in liters, so if we took their volume, okay, tons, or molecules, okay? And sometimes we are going to express a value in molecules, and I'll show you how to do that later, okay? But we can't count all the particles in a substance. First off, they're too small to see. Okay? We can't see atoms, even with the most powerful microscope. We can't really resolve them accurately. Okay? So it would be impossible to just start, okay, I've got this 1, 2, 3, 4. Well, if you were even counting the ones in an incredibly small sample, like 5 years later, you'd be at like 75,892,400. Crap, lost count. 1. But it would be impossible. Okay? You would just never be able to count them all. Even if you could see them, it would take your whole life to count the amount of atoms in a small sample of something. Okay? So we don't usually do that unless we're calculating it based on the mass of the material. Okay? So we use this, the mole. Okay? M-O-L-E, which of course, because we're so busy, we abbreviate M-O-L. It is pointless. I agree with you 100%. But Carson, this is a society that has an abbreviation for at. We're clearly very busy. Okay? Yes, but it stands for at, right? Because it takes too long to write AT. It's quicker to press Shift 2 and get that, right? Okay. All right, so the mole, like we said, represents always this number of particles. If I have 1 mole of water, I have 6.02 times 10 to the 23 molecules of water. Okay? If I have 1 mole of, let's say, calcium, then I have 6.02 times 10 to the 23 atoms of calcium. Okay? It's always going to be the same number. 1 mole always represents this, in the same way that it doesn't matter whether I have a dozen eggs, a dozen donuts, or whatever, it's always going to be 12. Okay? It always represents the same number. Right? Now, obviously, if I have 1 mole of lead, it's going to be heavier than 1 mole of calcium. Why would that be? Well, so is calcium. They're both metals. But lead atoms, okay, if we go down here, lead atoms have 82 protons in them. Calcium atoms have 20. They're simply bigger. So if I have, okay, 6.02 times 10 to the 23 atoms of lead, it's going to have a greater mass than the same number of calcium atoms because the atoms are bigger. Okay? Everybody follow me there? All right, so this number here is Avogadro's number. You won't have to memorize it. It's on, I think it's on your periodic table, even if it's not. Okay, you can write it on there. It'll also be on the front of your unit exam next week. It's not a number I expect you to memorize, although you'll probably inadvertently end up doing so. It's not that hard to remember. Okay. All right, so Avogadro's the guy who came up with this. Question so far on what the mole is? All right. Last week we were dealing with balancing equations, okay? And when we balance equations, we put those coefficients in. Okay, those coefficients, more often than not, represent the number of moles of something. Okay, so when we have a 1 in front of something, it's 1 mole of that material. If we have a 5 in front of something, it's 5 moles of that material. More often than not, that's what we're using those coefficients to represent. Instead of 5 molecules, 1 molecule, it usually represents 5 moles. All right, sometimes we've got to calculate how much, or what is the mass of 1 mole of a material? Okay? Periodic table tells us what the mass of 1 mole of all the elements is. Okay? But that doesn't, I don't have a periodic table that has the molar mass of every compound in existence, because that would be huge. Right? It's much easier to just calculate the molar mass of a material based on its chemical formula. So if I'm looking at, for example, here we have water. Okay? How many hydrogen atoms are in water? 2. Okay? How many oxygen atoms? 1. All right. Molar mass of hydrogen is 1.01 according to your periodic table. So if I want to calculate what is the mass of 1 mole of this stuff, I take the molar mass of hydrogen, 1.01, and I multiply it by how many hydrogen atoms there are. 2. And then I add that to the molar mass of oxygen, which according to your periodic table is 16.00. Okay, so 2 times 1.01 is 2.02 plus 16, 18.02 grams per mole. Okay, that's how we calculate molar mass of a compound. We take the mass of the elements that are in it, okay, and add them up. Right? Keeping in mind that we have to also reflect how many atoms of each thing are in there. Right? I multiplied hydrogen's mass by 2 because there were 2 hydrogens in here. Okay? I didn't multiply oxygen's mass by anything because there was only 1. Okay? Is that making some sense how we do that? Okay? That's the easiest part of the mole calculating, is calculating the molar mass. Now, I want you guys to calculate the molar mass of those compounds. I'll give you a couple minutes to get ahead of me, and then we'll go through them together. Okay, let's have a look at 1 and 2 here, just to kind of have a couple more examples to look at. All right, so I got to calculate the molar mass of sodium chloride. How many sodiums in this? 1. All right, so sodium is 22.99 grams per mole, okay, and chlorine 35.45, right? Okay, grams per mole. There's only 1 of each, so I don't need to multiply either one of those, okay, by anything. I just need to add them up. Okay, so 22.99 plus 35.45, okay, gives me 58.44 grams per mole. How important are units? Very important, because an answer without units is meaningless and thus also wrong. So you always want to have units on your answers, okay, when you're doing some calculating. All right, number 2, I got iron with bromine. So iron's 55.85. Okay, so we got 55.85. How many irons are there? Just 1, right? No, not the charge. How many iron atoms? 1. There's no subscript next to it, right? So there's 1 iron atom, but there are 3 bromine atoms, and bromine is 79.90, I believe. Okay, so my 1 iron, my 3 bromines, okay, and I add them up. So 55.85 plus 79.9 times 3. All right, so we got 295.55 grams per mole. Okay, so it's pretty important to be able to read a compound and know how many of everything there is in it. Okay, and that gets even trickier when you've got polyatomic ions, like in number 4 here. Okay, so in ammonium, how many nitrogens are there? 1. And how many hydrogens? 4. But in this compound, there's how many nitrogens? 2. And how many hydrogens? 8. All right, you got to keep that in mind. You got to be able to read compounds correctly so that you can add them up the right way. Okay, keep going there. All right, so for number 3, okay, we've got diphosphorus pentaoxide. Okay, so we've got to go, is it 32.05 for phosphorus? No, 30.97. Okay, so we got 2 times 30.97. That'll take care of our phosphorus. And we've got to add that to 5 oxygens. Okay, each one of them being 16 grams per mole. All right, so when we add those together, okay, we've got 2 times 30.97, okay, and we're going to add that to 5 times 16. All right, so we got 141.94 grams per mole. Okay, questions on number 3. All right, how many people have done number 4? Okay. So we said before we got 2 nitrogens in this compound. You got to do it atom by atom. You're not going to find molar masses for ions, only for atoms. So there's 2 nitrogens, so that's 2 times 14.01. Okay, that's nitrogen. And then we got 8 hydrogens, so 8.08. Okay, 8 times 1.01. And then we got how many sulfurs? 1. All right, and that's 32.07, I believe. Okay, and we have how many oxygens? 4. All right, so when we plug this one in here, we're going to have 28.02. That's our 2 nitrogens, okay, plus 8.08, our 8 hydrogens, and our 1 sulfur, and our 4 oxygens. All right, so we're looking at 132.17 grams per mole. Okay, and that's pretty involved. Usually on a test, if I'm testing mole equation stuff, it's fairly simple compounds so that you don't spend all your time calculating the molar mass. Okay, but it's still important to be able to read a compound's formula correctly. All right, and for the last one here, we got scandium carbonate. Okay, so we got 2 scandiums, and I never remember what that one is. 44.96. Okay, so 2 times 44.96 for the scandium. Then how many carbon do I have? 3. Okay, so 12.01 times 3. Okay, and how many oxygens do I have? 9. All right, so 2 times 44.96 plus our carbons, and then plus our oxygens. All right, 269.95 grams per mole. Okay, pretty straightforward on how to calculate molar mass. All right, because you're going to have to do that on basically every mole equation question. You'll have to calculate the molar mass of your material, right? Because you're going to use it to calculate either the number of moles, or the mass of the material, or the number of molecules in the material, okay, or something like that. All right, so like we were saying here before, when we write a chemical equation, these coefficients can represent a number of different things. They could represent that we have 1 molecule of nitrogen gas, 3 molecules of hydrogen gas, and that's going to make 2 molecules of nitrogen trihydride, or ammonia. Okay, that could be the thing that's going on there. Or it could mean there's 1 mole of nitrogen gas, and there's 3 moles of hydrogen gas, and there are 2 moles of nitrogen trihydride, which is the most likely explanation for what we have there. Okay, and if we have 1 mole of nitrogen gas, what's the molar mass of this stuff going to be? Okay, how many atoms of nitrogen are in a molecule of nitrogen? 2. Okay, that's a molecule of nitrogen. It's 2 atoms bonded together. Okay, it's one of our molecular elements, one of our special ones. Right? So if every nitrogen is 14.01, this is going to be 28.02. Okay, the molar mass of this stuff is going to be 28.02. Okay, I'm going to add that to 6.06 grams of this stuff. Okay, and I'm going to end up with whatever 28.02 and 6.06 add up to. Right, because my products can never have a greater mass than my reactants. Okay. Now, that's something we call stoichiometry, and it is something you will do basically the very first day in Chem 20. Okay? You'll use the mass and the number of moles of something on this side to figure out the mass and moles of something on the other side. Okay? And it's actually not as hard as it sounds. Pretty straightforward stuff. Okay. right, so like we said, it could represent particles. So this is 1 molecule plus 3 molecules gives me 2 molecules, okay? Or it could be moles. Oh, this is Avogadro, by the way. Kind of looks like a mole, right? Kind of got those kind of big eyes and no neck. Right? Just goes straight from his head to his shoulders. Right? I'm sure it's just the cut of the suit that makes him look that way. Like this went out of style 100 years ago, but yeah, get the idea. So if we had that, it could represent the number of moles. Okay, 1 mole of nitrogen gas, 3 moles of hydrogen gas gives me 2 moles of nitrogen trihydride. Okay, and we could use mass as well. Okay, all right. Here's the mole equation. N, which represents the number of moles, equals little m, which is mass in grams, divided by molar mass, okay, which is in grams per mole. And that's big M is the thing we can always calculate because we're always going to have a periodic table. Okay, they're not going to say, hey, calculate the number of moles of an unknown compound, because that would be impossible. Okay, we wouldn't be able to calculate that without big M here. Now, unfortunately, in chemistry, a major mistake was made in the making of this formula. There are 26 letters in the English alphabet. This is a 3-variable formula, and M is used twice. Okay? There's one that's small and one that's big. You got to tell them apart. But the even bigger mistake was the only other letter they used is the one that sounds like M. N. So the mole equation is N equals little m over big M. N is M over M. Yeah, it's horrible. That's the way chemists work. Okay? Unfortunate. Now, we're going to need to be able to move things around in this equation. That is, manipulate this equation to solve for things other than N. Okay? So you might get a question that gives you N, and of course you'll always have big M because you can calculate from your periodic table, and it'll ask you to calculate little m. How are you going to do that? You're going to use this equation, but how do you solve for little m? Okay. You're on the right track. I'm going to switch it. How do I get little m by itself? Multiply what? See, that's the problem with this equation, right? M by n, yeah. Okay, which m am I going to move over here? Big M. And I'm going to move big M over to here by multiplying it, because I'm doing, when I move something, I do the opposite, right? Okay, how many of you are thinking about this right now? Don't admit it, because I'll kill you. No, using a triangle. Good, because it sucks. And it fails you right after this, okay? So if you were thinking about using a triangle, stop thinking about it. Because we don't use triangles in high school. They suck. And they're a crutch, which I will kick out from underneath you. I'm that kind of person, okay? Because here's why. If you always use that crutch, you'll never learn to walk on your own. Okay? It is deep. Okay? Here's the thing, guys. A triangle works great if your formula looks exactly like this. There's only one other formula you're going to use in this class that sets up like this one and would work with a triangle, and that's this. Wonderful. If I only had to use those two formulas, sure, I'd use a triangle, because then I wouldn't have to think or learn anything, but that's not the way life works. Because you will use this formula. Last time I checked, a triangle only has 3 sides. This equation has 4 things in it, so it doesn't work anymore. Okay? It ceases to be effective. Or this one, E equals 1/2 mv squared. Pretty hard to use a triangle when one of your things inside of it is squared. Okay? It doesn't work. Or when you get to physics 20 and you got to use this one. T equals 2 pi times the square root of L over G. Okay? Or this one. This is the granddaddy of them all. F1 equals F0 I challenge you to use a triangle for that one. It's got pluses and minuses. You have to decide halfway through that equation whether you're adding or subtracting on the top or adding and subtracting on the bottom, and then manipulate. Okay? So here, that's a real formula. That's for the Doppler effect. No, because most people just go, it's easier to learn how to do algebra right, because it is. Okay? So here's what I'm going to show you. Not all of this stuff. Okay? This is just to prove to you how useless triangles can be. Okay? And I know that somewhere along the way, someone has taught you that triangles are how you do math, except that they were wrong. Okay? And now I'm going to spend time teaching you how to do algebra, even though I don't really have time to do that. Okay? So here's what you need to remember about algebra. First off, it's not as hard as you think it is. Okay? There's 2 1/2 rules in algebra. Okay? 2 1/2 rules. Right? The first rule of algebra, you're going to want to write this down because it's good stuff. Okay? Write it anywhere. If you want to move something in an equation, okay, do the opposite operation. That's rule number 1. So if I'm dividing by something and I want to move it, I multiply. Right? Which is exactly what we said we would do if we wanted to move big M. We said we would multiply it over to here, because right now we're dividing by it. Multiplying is the opposite of dividing. Okay? The second rule of algebra. What you do to one side, you do to the other. The golden rule of algebra, we call it. Whoop. Okay, so what you do to one side, you do to the other. Okay, the last rule is rule 2 1/2. The reason it's rule 2 1/2 and not rule 3 is it doesn't get used all the time. There are lots of algebraic situations, including the one we're about to go over, where you won't use this rule. Okay, so it's only half a rule. All right. Move what's not attached to what you're looking for first. You're not going to apply that rule in this one, okay? And there's going to be lots of times where you won't apply that rule. That's why it's only a half rule. Okay, I know lots of people come into grade 10 and they're like, oh, I'm awful at math. And I know I'm guilty. I say that all the time too. Okay, I say I'm awful at math. I can do algebra though. Okay, algebra is like grade 7 or 8 math. Okay? In fact, I saw something in my grade 3 kids' homework the other day that was the beginnings of algebra, and I was like, oh my gosh. Okay, right. Find what the something is. Exactly. Yeah. 5 plus x equals 10. So they were already kind of starting that stuff then, right? So it isn't difficult to move things around in an equation. You might think it is, but once we start doing it, you'll realize it really isn't that hard, okay? What becomes more difficult is when you start getting into all that like quadratic stuff and what's that? The F word. Factoring, that, right? Yeah, yeah. See, I find it hard. Okay, there you go. Okay, and second semester, this always goes better than first semester because you just got out of grade 9 and you had a summer off and you forgot everything. Okay, and yeah, it's awful. Okay, so here's what we got to do. You're only going to use this equation. You're only going to use this equation to solve for n and for little m because big M you're always going to have. You're never going to have to manipulate to solve for big M because you always get it off the periodic table. So If I want to solve for little m, I need to move big M. I need to get this by itself. And we just said, since I'm dividing by big M, if I want to move it, I do the opposite. I multiply both sides by big M. Okay? So when I do that, really, this is what I'm doing. Okay? I'm saying, all right, I'm going to multiply this side by big M. Well, with a big M on the top and a big M on the bottom, it will cancel, because M divided by M is 1. Okay? And then I got to do the same thing, rule number 2, to both sides. Big M times N equals little m. Okay? That's the only manipulation of that formula you're actually going to have to do. Okay? It's already set up to calculate number of moles, that's little n. Okay? The only other thing you're going to use it for is to calculate little m, mass in grams. Like we said, big M you're always going to have, because you can always get it off the periodic table. All right? So that equation is nothing to be intimidated by. It's also nothing that needs a triangle. If I see you draw a triangle on your paper somewhere, oh God, don't do that. Okay? I'll flip out. I will absolutely flip out. Okay? Yeah, good. So no one taught you the triangle? Good. Okay? If someone taught you the triangle, don't tell me who they are, because I have to hurt them. Okay? All right. Everybody follow that manipulation? Okay. Now, another thing that we're going to run into is using Avogadro's number. Okay? Remember that Avogadro's number, 6.02 times 10 to the 23, is the number of particles in 1 mole. So if a question asks me, calculate the number of molecules or particles in this much stuff, so let's say it's like 10 grams of hydrogen chloride, okay? I'm going to have to find out how many moles there are. Okay? No, I said there's 10 grams, right? So there's going to be more or less moles, right? Okay, so I got N, and we're told that it was 10 grams of hydrogen chloride. Okay? Since they told us it was hydrogen chloride, could I figure out big M for hydrogen chloride? Yeah, it's going to be 1.01 plus 35.45, right? So we're looking at 36.46, right? Yeah. Okay, so if I do that, is that going to give me N? Okay. So. All right, so that's going to give me 0.274 moles. So it's less than a mole. Is that okay? Yeah, it's okay to have less than a mole. It's like having a quarter of a dozen, which incidentally is 3. Okay? All right, so we have slightly less than a full mole. That's all right. Now I know what N is. But the question asks me, how many molecules, not how many moles are there? Well, I know I have this many moles, and I know that there's this many particles in 1 mole. So how do I figure out how many molecules there are? I don't have this many. I have less than this, right? Because this is how many there are in 1 mole. I only have this many moles. No, because remember, this is a number like a dozen. Okay, it represents 1 mole. I don't have a mole. So let's figure this out. If I just did this for you a minute ago. I said, like, if I had a quarter of a mole, by the way, that's 3 eggs. Okay? Or, sorry, I said 3. A dozen eggs. If I have a quarter of a dozen, I only have 3 eggs. Everybody follow me there? How did I do that? Yeah, it was math. Okay? I multiplied 12 by 1/4. Okay? Could I do the same thing here? Take the amount in moles that I have, this is 0.274 moles, okay, and multiply it by how many are in a mole. Would that give me how many molecules I have? Sure it would. Okay? By the same reason that this worked. Okay? If I have 12 eggs per dozen, okay, and I multiply by 1/4 of a dozen, what happens to the dozens? They cancel off and I'm left with how many eggs I had. Right? In this case, it would be 3. So when I do this, I multiply the number of moles by the number of particles in a mole. Moles cancel, and I'm left with how many particles I have. Okay? Pardon me? So, yeah, okay, so now we're going to calculate it. How do I punch that god-awful number into my calculator, is what you're thinking. Yes, with a scientific calculator, okay? But you can do it on your phone as well. The key is to use brackets. Right? So I'm going to take first my number of moles, 0.274, and then I'm going to multiply it by Avogadro's number. So I start with a bracket, and then I punch in the 6.02. Now I need this times 10 to the 23. Well, I actually don't punch in times 10. I use the exponent tool, okay, which is right here with the comma if you have a TI-83. If you don't have a TI-83, you're looking for EE, okay, 2 capital E's, or you're looking for an EXP button. Either one will work, okay? When you hit it, it'll give you a little E, or, well, actually a capital E, but small. Okay? And then you can punch in the exponent. That little E means times 10 with this exponent, 23. Right? So when I put in Avogadro's number, that's what it looks like in my calculator, 6.02 E23. On some calculators, when you put EE, it actually shows a small times 10 with the thing above it, okay? Because I do. Because the calculator put it there. E means, like our number system is a base of 10, right? Every time you move forward one more, it's 10 times greater. So what this is saying is, how many 10 places am I moving? I'm moving 23 10 places. Yeah? Okay, so when I punch that in, there's my number. That's how many molecules of hydrogen chloride there are in 10 grams. Okay? What do you mean, doesn't it keep going? Okay. No, this number doesn't. Okay, so here's what I've got then. Okay, I've got 1.65, okay, because I would round it, 1.65 times 10 to the 23 molecules of hydrogen chloride. Right, so I would write that like this. 1.65 times 10 to the 23 molecules. Okay, you only have to use Avogadro's number if the question gives you molecules or asks for molecules. The rest of the time, you won't even use it. Okay, so if a question says, how many molecules are there? You're going to be using Avogadro's number after you do a mole equation question. Okay, if it gives you the number of molecules, you'll have to use Avogadro's number to calculate the number of moles, which is the opposite of what we just did. Okay, and then you could use the mole equation after that. We're going to go through one of each kind of those right now. Okay, so we're about to go over 4 examples of the mole equation. Okay. So write these down. You're going to want all of these examples in your notes so you can refer back to them. And I'm also going to show you my marking scheme for a mole equation calculation. So we're looking for how many moles of calcium chloride there are in 90 grams. This is the easiest of all the mole equation calculations. Okay? Our first step is to write down anything the question outright told us. Okay? The first thing the question outright told us was mass, 90 grams. So that's little m is 90 grams. And this is where it's important too to remember what each part of the equation stands for. Little m is mass in grams. Big M is molar mass in grams per mole. N is moles. Okay? All right, it's asking for moles, so we know we're looking for that one. Okay? We don't know what N is. That's what the question's asking us to find. The other thing it told us was we're dealing with calcium chloride. Can I calculate big M if I know what material I'm working with? Yes, I can. All right, so big M, calcium chloride. Okay, so that's going to mean calcium's 40.08, and there's only one calcium here, okay, plus 2 chlorines, 35.45. 110.98, is that right? I did. That's 70.90 plus 40. Right? 7 plus 4 is 11, 110. Yeah, I'm pretty sure I did that right. I cheat a little bit when I do stuff in my head. Okay. All right, so I've got little m and I've got big M. So, got 1 mark so far. Okay, you got a mark for writing down the givens in the question, calculating molar mass. Then, you got n equals little m over big M. Do I have to manipulate that at all? No, it's already set up to calculate n. All right, so I just have to plug in my numbers. Little m was 90 grams, and big M is 110.98 grams per mole. That's your next mark. You correctly substituted in to the formula. Okay, and your last mark will be for your answer. 90 grams divided by 110.98. Whoop, need a decimal in there. Okay, so I got less than a mole. That's okay. I got 0.811 moles. Right? You don't have to carry all the decimals. You can round off to 2 or 3 decimal places. Okay. What if you just wrote 0.811 here? How many would you get out of 3? 2. Because it won't give you a mark for an answer without units unless, well, no, it won't work out for you guys. But in Physics 20, there's actually one situation where you run into a kind of problem you solve and it actually ends up with no units. Okay. Everybody follow me on that one. So that's the easiest one. It's only out of 3 marks because you calculate your molar mass, you plug numbers in, you don't have to manipulate, you get your final answer. 3 marks. Okay? That's the easiest one. Questions on that one? Okay, second type of question you can run into. What's the mass of 4.5 moles of magnesium bromide? And this is how I would ask it on a test. I wouldn't give you the formula. I would give you the name. Does that make it more difficult? Because if you screw up the formula, you're not going to get the right answer. That is, if you do not swap and drop magnesium bromide correctly, you will get the question wrong. Okay, so it's important to be able to do our swaps and drops. Okay, what's the mass of 4.5 moles? Okay, moles is N. So I know N, 4.5 mole. Okay, what is the mass? That means I'm looking for little m. And it's magnesium bromide. So when I have magnesium and bromine together, this is a +2, this is a -1. So I've got MgBr2. First semester, I put, it might have been calcium bromide, there's something bromide on the unit exam as one of the mole equation problems. Half of people got it wrong because I wrote it like this, and they didn't drop and swap. Did everything else right, didn't drop and swap, as a result did not get the molar mass right, couldn't get the answer right. Okay? Most of them got like 2 out of 4 because I gave them a mark for their givens, okay, and for manipulating the equation right, but not having the right numbers in it. All right, so you want to make sure you do that correctly. All right, so for magnesium, we got 24.31 grams per mole, and there's only 1 magnesium, okay, plus our 2 bromines. All right, so we got a molar mass of 184.11. All right, I've got N, I've got big M, and I'm looking for little m. So N equals little m over big M. Do I need to manipulate this time? Yes, I need to get little m by itself, right? So I need to move big M. Right now I'm dividing by big M and I want it to move over here. So I multiply both sides by big M. Now little m is by itself. All right, so you got 1 mark for your givens here, okay? And now you're going to plug in your numbers. So you'd probably get a mark for manipulating the equation. Okay, I would give you a mark for your algebra. And then give you another mark for 184.11 multiplied by 4.5. Okay, I'll give you a mark for plugging in your numbers in the right spot or substituting in. All right, so we're going to have 828.50 grams. 4 marks. Okay, does everybody follow what I did there? Okay. They all work pretty much the same, right? Does anyone still need that one? All right, now we're going to move into the last 2 examples. The last 2 examples are both going to use Avogadro's number. That's 6.02 times 10 to the 23. Okay, so they're basically going to add on an extra step. Okay, whenever you got to use Avogadro's number, it puts on an extra step. All right, so question number 3 is asking us to calculate the number of molecules, not the number of moles, although we have to calculate the number of moles in order to calculate the number of molecules. Okay, my givens are mass, 600 grams. Okay, and they tell me the material, silver nitrate. So Ag with NO3. That's a -1, that's a +1, so that compound is okay as written. Okay, things I don't have, N, and I also don't have the number of molecules, which is what the question's asking for. Okay, so even if you had no idea how to calculate the number of molecules, could you calculate N at this point? Yes, you could, and that would be a good idea. Okay, just because you maybe don't know how to get to the end of a question doesn't mean you should leave it blank, right? Because for this one, even if once you calculated N, if you still didn't know where to go, you're still going to get some part marks for getting that far at least. Okay, the worst thing you can do, guys, on a unit exam, especially one where there's part marks, is to leave something blank. Because what can I give you for that? Nothing. Okay, absolutely nothing. Okay, so you got to show your work. Okay, so for right now, I'm going to calculate N. N equals little m over big M. I don't have to do any manipulating for that one. I just need to plug in my numbers. Yes, sorry. I was thinking I'd already done that. I got to calculate big M first. All right, silver's really heavy. It's like 105 or something, 107. 107.87. And then I've got 1 nitrogen, 14.01, and I've got 3 oxygens. All right, so 169.88 grams per mole. All right, now I can calculate N. N is little m over big M. Okay, so that's going to be 600 grams divided by 169.88 grams per mole. Oop, 600. Come on. Okay, so I got 3.53 moles. Okay, so to this point, you'd have got a mark for your calculating the molar mass. Okay, you'd have got a mark for your calculation of number of moles. Okay, now I have the number of moles, but I'm looking for the number of molecules. And we said anytime you've got number of molecules, you're going to be using Avogadro's number. So this is how many there are in 1 mole, but I have 3.5 moles. How do I figure out how many molecules I have? multiply them. Exactly. Okay? So 6.02 times 10 to the 23, okay, times n, okay, times our number of moles. All right, so that's going to be 6.02 times 10 to the 23 times 3.53 moles. All right, so you would get a mark for realizing you had to do that and plugging in your numbers. Okay, punch in Avogadro's number. And guys, if you do not enclose Avogadro's number in brackets, it really messes things up. Okay? Because either it thinks that you're multiplying the base by this, or if you write in your answer afterwards, it thinks that it's part of the exponent. Okay? And then it really messes things up. So always make sure you got Avogadro's number in brackets. Whoops. Delete. All right, so we got 2.13 times 10 to the 24. Molecules. Okay, so that would be your fourth and final mark for that one. When I multiplied the 6.02 by 3.53, it ended up being greater than 10. But we always keep the numbers between 1 and 10, so we add one more power of 10 onto there. Does that make sense? Because what this actually came out to was 21.3 times 10 to the 23, but we don't write it that way, right? We always shift it back. Okay, questions on the third type? Okay, fourth type. And like I say, guys, there are literally only these four types. Okay, there are only four ways I can ask you a mole equation problem, and I'm going to show you how to solve all four each day this week. Okay, so you have lots of examples. What is the mass of 1.54 times 10 to the 25 molecules? So that's the first thing they gave me, number of molecules. Okay, 1.54 times 10 to the 25, okay, of diphosphorus tetraiodide. Okay, diphosphorus tetraiodide. Right, and I'm looking for little m. If I want to get little m from the mole equation, I need big M and what else? If I want little m, I need n. Right, I need big M and n. Those are the two things that I need. They did not give me n. So there's got to be a way for me to find it. All right. Since we said anytime they mention number of molecules, either asking you for it or giving it to you, you know that you're going to be using Avogadro's number. So let me ask you this. How many dozen donuts do I have if I have 36 donuts? 3. I have 3 dozens. How did you do that? Okay, you went 12 times 3. I was thinking you went 36 divided by 12. Okay? You go 36 divided by 12. Does it give you 3? You can check on your calculator. I'm pretty sure it does. Okay? It's 36 divided by 12. So what I did is I took the number I had and I divided by the number in a dozen. And that left me with the number of dozens, 3. Okay? So in this case, I need to do the same thing. I need to take the number of molecules I have and divide by the number of molecules in 1 mole. That'll leave me with the number of moles. Okay? It's the opposite of what we just did. We just multiplied moles by Avogadro's number and got molecules. Now we're dividing molecules by Avogadro's number to get moles. No, you got to use the whole thing because remember, this is 100 times bigger than this number is. Okay? If I just use their bases, I would have to move the decimal over 2 spots. It's just as easy to just punch it in. Okay? All right. So to get n, I'm going to have to go, okay, 1.54 times 10 to the 25 divided by 6.02 times 10 to the 23. Okay? So you get a mark Sorry, we haven't calculated big M yet, but you would get a mark here for that step. Right now, let's just get N. So again, you got to put that all in brackets. 1.54 E25. Whoa, not what I wanted. E25, N bracket, and then divide that by Avogadros number, also enclosed in brackets. Okay, so I've got 25.5 or 25.58 moles. Okay, so now I have N, 25.58 moles, right? I'm looking for M, so I need N and I need big M. I don't have big M yet, but I can calculate it. All right, so phosphorus we said was 30.97. Okay, so 30.97, and there's how many? 2. Okay, plus 4 iodines. Iodine is big. 126.9 times 4. Okay, so we got 30.97 times 2 plus 126.9 times 4. All right, so our molar mass of our diphosphorus tetraiodide is 569.54 grams per mole. Okay, now I'm back to the mole equation. I have N and I have big M. Can I calculate M? Yes. All right, so we got 1 mark for our givens. Okay, we've got 1 mark for this step here where we calculated our number of moles. Now we've got N equals little m over big M, where we need to get little m by itself. So we multiply both sides by big M. There's a mark for your manipulation. So we're up to 3. Okay, now we plug in our numbers. So that's going to be our 569.54. Okay, our molar mass multiplied by our number of moles, which we calculated over there, 25.58. Okay, so this is M, big M, sorry, times N, and that's going to give us little m. All right, do we have a lot of this stuff? Yeah, that's 14.5 kilograms. Okay, that's roughly 30 pounds of this stuff. It's a lot. I don't know what you use diphosphorus tetraiodide for, but you have a lot of it. Okay, you got about 30 pounds of it. Okay, so we would write that, okay, as 14,000, what was it, 568, 83 grams. Yes. Okay, and that would be, so you get a mark here for your substitution, okay, and then you would get a mark for your final answer. So that one, 5 marks. Okay, so the easiest ones are 3, okay, the middle ones are 4, that one with the most steps is 5 marks. How many should you expect to see on your unit exam? Probably all 4, yeah. Okay. On the final exam, I asked 2 of the 4. Okay, on your unit exam, expect that I'll probably ask all 4. Okay. Now, you're probably looking at that right now and going, oh my God, it takes too long. But trust me, they all work pretty, once you identify which of the 4 types it is, it's just mechanical. Okay, you'll be able to go through those pretty quickly. Okay. Probably not. Just so we can get through all this mole stuff. Okay. Now, also this week, okay, I'll be giving you your unit exam review package. Probably on Wednesday I'll give that to you. And what that will contain are some suggested activities for you to do, some sample questions for you to do with the course a key, and I will also give you a sample test. Okay, it's basically a test I don't use anymore, and it's got well, it's shorter than the one you would get in class, but you'd have like about 20 or 25 multiple choice and maybe about 6 or 7 problems. Okay, yours will be a little longer than that in class, but at least it gives you an idea of what kind of things I'm going to ask, how I'm going to word them, okay, things like that. So definitely, guys, do the review package I give you as part of your preparation for your unit exam. If it is the only thing you do, I don't know if you've done enough then, okay? But it should certainly be a big part of what you do, okay? The other things you should start thinking about doing, reading over your notes, okay? Looking over your lab reports. I mean, you're going to get your reactions one back here on Wednesday. Okay, look over those. Look over any worksheets that I've given you. Pick a few at random off of there. Just make sure you can still do stuff from those. Okay, those are the kind of things that are going to wind up on your test. Okay, and of course you got all this week. Come in and see me for help. Okay, if you need it. So make sure that you are asking questions if there's things you don't get. But if you wait till this weekend to start your preparation, you will not be able to ask me questions because you write on Monday morning. Okay. Your exam is now only 1 week away. Pardon me? Yes, that's why tomorrow and Wednesday we're doing pretty much the same thing, so that the people that miss tomorrow will get it on Wednesday. Those of you that are here both days, you get it both days. You'll be that much better at it. Okay? No, there won't be a quiz. I already said that. You should pay attention. Oh, I recorded that. That's too bad. Okay. Yes. Show me the manipulation. Show me this, because it's worth a mark. Okay, so show me what you did to change it around. Yeah. Okay. Now, the copier didn't spit this out this morning when I asked for it, so I'm going to try and make another copy of it here. But this is where you're going to start with. Okay? These are some simple kind of mole questions. Okay? The first one here is asking you how many atoms or molecules are present in these. Okay? So it's telling you the number of moles and asking you for the number of atoms or molecules. Okay? Question number 1, people sit there and stew over that one forever when it's the easiest one up here. Okay? How many atoms are there in a mole of anything? Right. What was that number? 6.02 times 10 to the 23. So what's the answer for 1A? 6.02 times 10 to the 23. In fact, it would have been that same number regardless of what I put here. Okay? I could have put any element I wanted there, and the answer would have been 6.02 times 10 to the 23, because that's how much there is in a mole of anything. Everybody follow me there? That should give you a hint as to how to do the next 3, okay? B, C, and D. So you can get started on those, and I'll get you a paper copy of this here right away.